Okay, this video will have two parts. I will start with talking about determinant. Sorry, I just want to do determinant. Okay. We are going to start talking about the determinant of a matrix. And again, like the identity matrix, okay, like the identity matrix, we are going to all, I promise we're going to all put this together in a third video, okay? Sorry, I'm just going to put it a little bit bigger. Okay, in the third video, I'm going to put everything, the identity matrix, the determinant of a matrix. This tutorial has another page about the inverse of a matrix, and you'll see how all of this ties in together, okay, in order to solve an equation using matrices. Now, let's use a matrix, a random matrix. I'm going to make it up right now, 2, 1, 4, and 3, okay. First of all, when you are asked to find a determinant of a matrix, I can ask you in words, find the determinant of this following matrix. And again, you don't know what a determinant is. You'll be like, wait, what? What is that good for? Again, remember, I hope you're writing all of this in your book and you'll see how all this ties together at the end. I can ask you in words, or look at this. I can ask you to 1, 4, 3 like this. Do you notice the difference between this and this? Okay, the first one has the little like brackets here. It's closing up. This is just a symbol for matrix. But if I have here just 2 lines without the box, that's also another way for me to ask you to find the determinant of the matrix. Okay, so like I said, just remember that that notation. Okay. Now we're going to start, and it's extremely easy, and I will not spend a lot of time on this. To find a determinant of a matrix, you have to multiply the first with the last, okay, the first diagonal. You're going to do 2 times 3, okay, which is 6, minus, remember, it's always going to be a subtraction. Unless what goes after the subtraction is a negative, then it turns into a positive, right? Careful to use your basic rule of arithmetics, always. Then you're going to subtract the multiplication of the middle and third number. 4 times 1 is 4 times 1 is 4. So 6 minus 4 is 2. That's it. The determinant of this matrix, the determinant of matrix, let's say matrix A, they'll put it like this, equals 2. That's it. Okay, you may wonder, why is it useful for? Well, we're going to the next page right now, and it's part of finding the inverse of a matrix, okay? So let's go. And again, we're working, guys, we are working in 2 by 2 matrices right now. We're not going to get into 3 by 3 or 4 by 4. When we will in the next class, we will be doing all of this on the calculator, okay? But by hand, you are only required to do by hand 2 by 2 matrices, okay? Now let's talk about the inverse of matrix. I'll use the exact matrix I used in the page before, so you see how the 2 that we found is used. Okay, and again, I'll give you the example and the application of why. Okay, so first of all, in order to find the inverse of a matrix, first you need to find the determinant. What we just did in the other page, remember? We did 2 times 3 minus 4 times 1. 4 times 1, which was 6 minus 4 equals 2. Once you have the determinant, you recopy your, Okay, I'm just gonna, okay, so once you have the determinant, just leave it there hanging for a second. Now, listen to this. This is a technique. In your book, you're going to see a different technique. I do not like that technique. I prefer this one. I think it's so much easier, okay? Let's write our original equation again, 2, 1, 4, and 3. Leave your determinant here. We'll put it somewhere after. The second step, I would say switch values. You're going to see what I mean by that. Switch your values inside your matrices. Okay, so what you're going to do is you interchange the first and the last. Okay, 3 and 2. You see what I just did? I interchanged my first here and my last. I just switch them. I don't change the sign or anything. I literally just switch those two values. And then what do I do with the two inner values? I change the sign, but I do not change them of position, but I change the sign. Okay, so please take a minute to pause and write this down. Step number 2 of finding the inverse of a matrix is to interchange the first and the last, okay, and the middle, 2 by 2. 2 by 2. Okay, so you interchange the first and the last, and then the two inner numbers, the middle numbers, like the 4 and the 1, you just change the sign. So if 1 was negative, it turns positive, and if it's positive, it turns negative. Okay, I'm just entering it in my calculator at the same time so I can double check everything. Okay. Sorry, determinant. Oh no, sorry. Okay. Good. So I just wanted to get the answer. So let's find the inverse now of this matrix. So the way we're going to do this is, listen to this. Do you see we changed that? Not that. I should have a little bit more room. I'm just going to put it a little smaller. I'm going to move it here. Perfect. Now what we're going to do is you take your determinant, and you insert it here as a reciprocal always. Guys, the matrix, the determinant of the matrix is not 1/2, it's 2. But it's always used as as a reciprocal. You're always going to put 1 at the top, and whatever answer you have, you put it as a determinant, you put it below. And now you do a scalar multiplication, like we did, as a simple part. What is 1/2 times 3? 3 over 2. What is -1 times 1/2? It's -1/2. Negative 1/2 times -4 is -2. And what is 1/2 times 2 here is 1. We found the inverse of our matrix here. Okay, so listen to me. We have learned about the identity matrix. We have learned about how to find the determinant of a matrix, and then we have found how to use the determinant of the matrix, flip it into a reciprocal, right? Putting it 1 over 2, whichever number you get here. And by the way, if it's negative, you leave it negative. And then you do a scalar multiplication, and you get the inverse matrix. Now you're probably like, what is all of this, right? So now the next video will explain how to get everything we've just done right now, we just did, and put it together in order to solve a system of linear equation, okay?